Jeremy Howard, Chief Scientist and President of Kaggle. A pleasure to have you here.
Thank you, Peter.
I'm extremely excited about how powerful the technology that you and your colleagues have created is, and how it can be really utilized by a small team or a Fortune 100 company to change the way they view data and information. If you don't mind, let's start with your quick overview of what you guys do.
Sure. So Kaggle is a new kind of company which is creating a whole new kind of work, a whole new way of doing work. And in doing so, it's shifting the technology curve in the number one most leverageable area of technology we have, which is machine learning and artificial intelligence.
Well, what is machine learning?
So machine learning is the ability for machines to come up with ways of working themselves, ways of solving problems themselves, just by looking at some data that you give them about some causes and effects. Machine learning is the most leverageable technology because it's something where machines can build on top of knowledge and data themselves. It doesn't need humans in the loop. In the long term, it's my strong belief that development of machine learning will eventually lead to strong artificial intelligence.
And you're a machine learning scientist, if you would, so you're someone who would program a machine to look at data, learn from it, and make predictions.
Yeah, my job is kind of to create those meta-algorithms. So I don't tell a machine, here's how you drive a car without hitting pedestrians, or here's how you play chess, or here is how you search the galaxy for dark matter. I create these kind of meta-algorithms that say, when somebody gives you data about causes and effects, this is the kind of stuff you might look for. This is what relationships might look like. And we know that the brain is basically a pattern matching machine. So my job as a machine learning expert is to build those pattern matching capabilities into computers so that they can do what we can do, hopefully only better. And in fact, in many, many areas of research right now, much, much better, whether it be winning Jeopardy or driving a car more safely than humans can.
So, going back to the big picture again of Kaggle, tell me what the value proposition is and how you guys work, and then we're going to dive down deep a little bit.
So Kaggle is a marketplace, and all the best marketplaces bring together two groups that are looking for each other. In Kaggle's place, we bring together people with really interesting problems to solve and lots of really interesting data that could help solve those problems, and tens of thousands of data scientists, the people that are able to look at data and figure out what's hiding in there, what are the insights.
There are tens of thousands of data scientists.
There are about 45,000 on our platform right now.
45,000 data scientists who are machine learning experts.
Yeah.
Are out there.
Right, and then in fact there's a lot more than that. And the interesting thing, Peter, is that very few of these people who are winning Kaggle competitions, and we'll come back to this competition idea in a moment, but very few of these people are first and foremost machine learning researchers. They're people that study glaciers or particle physics or electrical engineering. They're people who every day in their jobs or their research are using data to solve problems. And nowadays, the way the best people do that is not by hand coding those algorithms in electrical engineering or glacier detection or particle physics. They actually do what I do, which is they create these meta-algorithms, these machine learning algorithms, and let the computer solve the problem for them. So it turns out these people, these 45,000 plus machine learning people who are applying themselves every day to real-world problems, can actually apply those exact same skills to other problems. And so that's why they come to Kaggle. And on Kaggle, they will find dozens of real-world problems with real-world data that people were desperate to get solved. For example, Ford were trying to create a system for their cars that would automatically identify if you're getting drowsy or you're not alert. And so they had lots of data about vehicle sensors and physiological data and so forth. And they wanted a predictive model that said, oh, looks like Peter's not concentrating, let's ring a bell or whatever. They put that data and that problem up on Kaggle, and within days, hundreds of people were finding out how to solve that for them. And of the people that did really well in that competition, none of them had a background in vehicle safety or in vehicle sensor systems or anything like that. They were people, like in every competition, from a huge variety of backgrounds. So what happens is, you and I could both compete in this Kaggle competition or any Kaggle competition. It would be as simple as going to the website. We can download the data for any problem that we find interesting.
So just to frame it, I'm the user, I'm Ford, I'm the insurance company, I'm whatever, I'm an entrepreneur, I have a whole bunch of data I've collected. And I upload this data in a certain format.
Let's give an example.
Okay.
So for example, let's look at Allstate. So Allstate
Insurance.
Allstate Insurance, live or die, depending on their ability to predict how risky a driver you are, how risky your car is, whether it be in terms of accident or getting robbed or so forth. They live or die by their actuarial models. If they could make it just a little bit better, they're going to do great. That's why they invest in dozens and dozens of the world's top actuaries who work in Allstate and work on this problem all day, every day. In order to get every possible advantage, they thought, what if someone in the Kaggle user base could do even better? So they decided to run a Kaggle competition to see if somebody could improve their vehicle risk models. So step one was they filled out a 5-step wizard on the Kaggle website. So step one.
How long does that take to do?
If you have all the data and know ahead of time what you're doing, it might take 2 or 3 hours. But
easy.
in practice, you probably don't. They're going to need, they need some help about, what would be the best set of data we could use, how much, should we anonymize it or not, what would be the best way we can describe this problem.
And you're able to advise them on this.
Right, so we give them advice about how to describe things in a way that regular data scientists can understand without having to be actuarial specialists or vehicle sensor specialists.
So step one, they upload, Allstate uploads this data.
Yeah, but the vehicle data, which has to include both causes and effects, or predicted things that might be causes and effects. So in this case, it'll be what kind of car was the person driving, whereabouts do they live, some information about that vehicle and so forth. That's all the stuff that you think might be related to risk. And then the effect, which is over the past year, how much did that person cost in terms of their claims.
Right.
And so the other thing they do in this wizard is they write a little description for the data scientist to say this is the nature of this problem, this is the nature of this data. They say how much prize they want to put up. In Allstate's case, I think they put up maybe $10,000.
They only put up $10,000.
Something very small like that.
And so how many data scientists, what were the data scientists being asked to do? Look at the data and do what?
And look at the data and come up with a model, a predictive model that predicts how likely each of a few 100,000 people are to crash their car, and in fact, more specifically, how much money that's likely to cost for each of those few 100,000 insurance risks. And they do that by building a model from all that other information about vehicles and areas and so forth. For a subset of those insurance risks, the participants actually know what happened. They actually know what last year's claims were.
So there was a built-in test case of you could
right. So that's what you can use to build your model
to validate it.
Well, then the validation then happens for the rest of it, where you don't know what happened. Allstate know what happened, and we at Kaggle know what happened, but the participants don't. So they use that model they trained on the rest of the data and apply it to this data where they don't know the outcomes.
So there's a set of training data,
Yep.
and then there's a set of test data.
Right, exactly. So the training data has the outcome, and the test data doesn't.
Okay.
And so then for the test data, you predict the outcome, you upload that to Kaggle, and Kaggle tells you in real time how accurate that model was. So as soon as you put it up, it'll tell you on the leaderboard where you are, this is your score, and you can have another go tomorrow and another go the day after. So you can actually watch yourself going up and down the leaderboard.
So you get to iterate your model and see which one actually gets closest to reality.
Yeah, that's right. And you can also see, how well other people are going. You don't know how they built their model, but you do know how good it was.
So a $10,000 bounty from Allstate had how many data scientists compete in this one?
I think there were about 300 or 400 teams, so that'd be about 600 or 700 individual data
Holy
scientists.
cow! So literally, the $10,000, not a very large amount of money, drove 600 data scientists that if they had to employ, they would have spent millions of dollars trying to
Right,
employ.
and they wouldn't have been able to employ most of them because most of the data scientists that competed were either full-time professors at major universities or they were people running research departments.
They're Google or Apple or
companies.
someplace.
Exactly. These are guys that aren't available to just pick up.
So they're working on this in evenings and weekends.
Right, exactly. And the $10,000 has very little to do with why they're doing it. That just makes it a bit of fun.
Yeah.
The reason people compete in these competitions is that it's a very, very creative field.
Yeah.
And so these creative people want to know how well are they doing? Who else is good in this area? If somebody beats them, they want to find out, what kind of person is doing well in these competitions. And in the public competitions, in fact, the top 3 will write up a brief description of the kind of approaches they took so you can learn from other people. If you do really well, then you find out, oh, this is an algorithm which is amongst the best in the world. If you don't do so well, then you find out where your gaps are. You can also learn a lot about your own process. So, for example, there's been some really interesting blog posts I've seen recently on the internet from people who have talked about how badly they've done in Kaggle competitions and how much they've learned about themselves as a data scientist in this kind of humbling experience of being unable to hide from the truth.
So, bottom line, how did these 600 data scientists do in the All-State competition compared to the internal actuaries?
So, in the All-State competition, All-State, of course, already had a vehicle model of risk, and that's something that they've worked on for some decades. And I'd say that actuarial team is one of the best in the world.
Yeah.
The predictive power of the model developed over 3 months in a Kaggle competition was over 300% more accurate than All-State's benchmark.
300% better. That's that's got to be worth not millions, but potentially hundreds of millions of dollars.
I would have thought so. I spent 10 years in insurance analytics, and that would be my
So,
guess.
so $10,000 drives them 600 scientists they could not otherwise hire, and hundreds of millions of benefit. That's an extraordinary
And the other thing,
return.
Peter, is not only could they not otherwise have hired those 600 scientists, but also if they did, they would not get nearly as much out of them. What we find is that this real-time leaderboard where people see other people, they were first yesterday. Today, Peter Diamandis comes and puts in his predictions, and he turns out it's much better and leapfrogs me, and now I'm in second. And I think, oh, what did that Peter find that I didn't find? And we found, I used to compete myself, and I definitely found that there were many situations where I thought I'd done the best I could possibly do, but then getting passed on the leaderboard pushed me to find things that I just didn't know was in me.
So you're chief scientist and president now, but you actually came into Kaggle as one of the top data scientists, if I remember correctly. Where were you? What were you doing back then?
Right. So I came from a philosophy education, strategic management consulting, built 2 startups, sold them, got to a point in my life where I had some time, I had some money, I had the ability to, do what I wanted to do. And at that point in time, Kaggle had just been developed by my friend Anthony, who is now my friend. I didn't know him back then. Somebody told me about Kaggle as being a great way to keep my mind more than active and work on some of the most interesting problems in the world. So one of the first problems I worked on was trying to replace the 50-year-old ELO rating system used for ranking chess matches. And so it's about creating a ranking system that would do a better job of predicting the outcome of a chess match than the old ELO system.
Mm-hmm.
I found it a fascinating process. I ended up coming second in that competition. I competed in 2 other competitions then, both of which I won. Bumped into the founder and CEO of Kaggle totally by chance. And as soon as I discovered that not only is Kaggle an Aussie company, but it was built by this extremely nice local Melbourne guy, and really enjoyed getting to know him. And when he met me, he immediately knew who I was, because nobody else had won 2 competitions at that stage. So, we hit it off very quickly. Teamed up, yeah. I invested some money in the business and couldn't keep my hands off it, wanted to get involved as much as possible.
And you've got some world-class investors in Kaggle at this point. Vinod Khosla is one of them, I know, a common friend.
Yeah, Vinod Khosla, as you know, Peter, is somebody who has what is a fairly unique approach to investing, and it's a shame it's unique. It's unique in that he actually looks for things that can really make a huge difference, which you'd like to think everybody's looking for, but frankly I've noticed a lot of people in the Bay Area invest in companies which look a lot like the last company that sold lots of money. Whereas Vinod actually looks a few years into the future and says, what could really make a big difference? And so, he was a great fit with Kaggle and still is. And, when I talk to Vinod, he is always talking about what's happening next and then what's happening after that, and really encouraging us to think about whatever we're doing right now, how could we make it much, much, much bigger?
Jeremy, you have some amazing success stories with Kaggle, and I'd love to give a few other examples so that people watching this, entrepreneurs watching this, CEOs watching this, can see how they could use it. So let's dive into 2 or 3 examples at the top level.
Sure. So some of Kaggle's most striking successes, or most obvious successes, are in the science and research areas. The reason they're particularly striking is because our successes in the commercial world, such as Allstate, I'm very proud of what our participants were able to achieve there, but only I can tell you that I know that Allstate's actuarial department is amongst the best in the world. And unless you are familiar with the insurance marketplace, it's hard perhaps for you to understand how huge an achievement that was. On the other hand, if I tell you that a Kaggle competition within 3 days had made huge strides into a problem that's been open since 1934 and has been worked on by many of the world's top minds for the last 80 or 90 years, that might be more interesting.
What was that one?
It was interesting enough that the White House, in fact, wrote about it on their website. It was the search for dark matter. So dark matter is this stuff that in 1934 was theorized must exist. When people looked at the amount of mass in the stars in our galaxy and realized there's not enough of it. There's just not enough gravity there to keep the galaxy together.
Right.
Clearly the galaxy is holding together, so therefore there must be something else. People have been looking for that something else for that whole time, and it's this theoretical stuff is called dark matter. Now, there's really only one thing we know about dark matter, which is it has gravitational pull. But one thing we do know about gravitational pull is that it can actually bend light. So some pretty smart researchers realized a while ago that if we look at really, really distant objects in the sky, so distant galaxies, we should be able to detect dark matter by seeing the light from those distant objects being bent. In other words, it'll kind of skew the shape of these galaxies. So all you need to do now to create a whole universal map of all the dark matter in the universe is to look at all of these distant galaxies and figure out how much they've been skewed. And that way you now know exactly where this dark matter is and you have a map of it. Problem is, gravity doesn't bend light very much because light moves quite quickly. Lots of other things bend light. For example, your telescope slightly bends light in ways that you don't want because it's just not a perfect lens. The atmosphere refracts that light and so forth. So there's lots of forms of error. And then when it hits your sensor, the CCD pixelates it again with kind of ways that create noise. So nobody had been able to use this algorithm to map dark matter. NASA, the European Space Agency, and the Royal Astronomical Society got together and worked together with Kaggle to see if the Kaggle data science user base could come up with an algorithm that was good enough. And within 3 days, all past research had been smashed. And it was smashed by a guy from Cambridge University, Martin O'Leary, who studies the movements of glaciers. He's a glaciologist.
So he's not an astronomer, he's not a physicist, he studies glaciers.
Right, he studies glaciers. But, funnily enough, when he studies that satellite image which is being refracted and pixelated and looking at a fuzzily edged, funnily shaped glacier, it sounds a bit similar, doesn't it?
In reverse. Right?
Yeah, so it turns out that some of the algorithms he developed, he was able to use fairly directly. And in fact, by the end of the 3 months, 15 teams had all surpassed all previous research, all using different approaches. And in fact,
Wow.
Some particle physicists ended up winning this competition. Their best result was over 300% more accurate than NASA's previous best algorithms. So all 15 groups were invited then to go to the Jet Propulsion Laboratory and work together with NASA on actually implementing these dark matter mapping algorithms.
So what I find extraordinary is how powerful a Kaggle competition can be for getting the smartest minds on the planet to focus on your problem for a relatively small amount of money. And I guess the challenge really would be what? The quality of your data and the quality of your question?
I think the challenge is the quality of your question. We actually find dirty data works better than clean data. And the reason for that is that the cleaning of data often removes the nuggets that, the stuff you thought wasn't important. So those missing values that you replaced with an average, for example, or actually the fact they were missing might have turned out to be something really interesting. Or you have these big text documents which you've turned into maybe some word counts or a few statistics about them, when actually there would be algorithms that could analyze the raw text of those documents directly and generate whole new meaning-based features out of it. So an interesting question and lots of potentially useful data which has been largely unmessed with are the things you need for a good Kaggle competition.
Do you have entrepreneurs coming in and using Kaggle as a tool to help them start a business?
There's a kind of product called a data product. And a data product is a product where it very directly is using the results of data as a product in itself. I'll give you a couple of examples. So, for example, there's a company that was recently sold called Flightcaster. And Flightcaster is this very simple little website where you say, this is my flight number, and it uses predictive modeling to tell you how late that flight is likely to be by studying things like the position of other planes at that stage, the inbound aircraft, the weather conditions, the past time series of that flight, and so forth. It's a very direct data product. Another example, in fact, by the same guy, is Prismatic, which is something that curates news from all over the web and then uses machine learning to predict which articles you're likely to enjoy, and curates a kind of a newspaper for you each day of stuff which it thinks that you're going to like. So these kind of data products are perfect for using Kaggle, because all you need to do is come up with the idea, find the data, and then the algorithm is going to get built for you, and you can know, based on over 100 past results, that you're going to get the best algorithm that's ever been produced in that area. So, for example, a company called Jetpack, which is actually founded or co-founded by a terrific data scientist named Pete Warden. This company, which is actually Vinod Khosla, is I think the key investor. Khosla Ventures is the key investor behind it. They have an iPad app which shows beautiful photos of places that you visit or places you would like to visit. And those photos are taken by your Facebook friends. Mm-hmm. The difficult thing is, what are beautiful photos? And it turns out that actually a machine learning algorithm can figure out whether a photo is beautiful or not. So Jetpack, when they first started, did not have a great algorithm, and their number one complaint that Pete tells me was, don't really like the photos, so what's the point? They ran a Kaggle competition, they took the winning entry and ran it in production. That's now what's running in the iPad app.
So the Kaggle competition actually comes up with an algorithm that you could own at the end.
That's right.
And use in your business.
That's right.
Whether it's looking at a beautiful photo or looking at a star field and trying to figure out where you are physically based on that star field.
Yeah, exactly. So if you download the Jetpack app now, you will see lots of beautiful photos, and I can tell you that behind the scenes is this Kaggle developed algorithm that's picking them for you.
Fascinating.
That cost $5,000.
That cost $5,000 and could launch a multi tens or $100 million company.
I mean, I know I saw in VentureBeat, or maybe it was TechCrunch, that they've had $1 million or $2 million of Kozla's money already in investments, so they've certainly tended to at least that much.
So, again, part of my message here is how to allow both entrepreneurs and successful CEOs to leverage the tools and techniques that exist to allow them to do what was previously prohibitively expensive. And so, let's say you're an entrepreneur, you're watching this conversation, and you want to create a data product, you want to create a website that provides a service based on information. How do they start?
Good question.
How do they begin?
So what the folks watching this need to most understand is what I call the analytics value chain.
Okay.
And then they need to understand how they can operate at each stage of that value chain. So the value chain is as follows. So starting with a premise, which is that you understand that data and the algorithms that generate insight and action from data is that number one most leverageable thing that you have at your disposal, that really the world of technology has at their disposal. How do you start leveraging that? Step one in the value chain is identify the problem you're trying to solve. A lot of people use a tools-first approach, which drives me crazy. It's kind of like, what data do we have? What tools do I know about? How could we use those data and tools? No, step one should be more of a consulting-based approach.
Right.
It should be, what would be the one thing that would change this company or this organization the most, that would make the biggest difference? Forget what you think the limitations are, because almost always I find people expect there to be limitations where in fact it's possible.
Right.
So throw away that
Preconceived limitations.
Yeah. And you say, okay, our business would be amazing, if only we could automatically translate human language, automatically find beautiful photos, have a car that not only is more fuel efficient but drives itself, for God's sake, or whatever. Step two is to put together a data set that contains both outcomes and all the things that might possibly be relevant. So,
and can you help an entrepreneur put that data set together?
Sure. So in fact, what I'll do is I'll go through the whole value chain, and then I'll describe how we can help each point.
Thank you.
Once you have a problem to solve and a data set, step three is now to build a predictive model. Step four then is to take that predictive model and implement it in your product. It could be online, it could be built into your car, it could be part of your how you price or whatever. At pretty much every one of these stages, Kaggle has a way of leveraging our over 40,000 data scientists to help you with that.
Mm-hmm.
So for example, the piece which is throw away all your preconceived ideas and think about what ways you could potentially transform your business by leveraging machine learning. You could use something called Kaggle Prospect. Kaggle Prospect is a thing where you can run a competition for people to come up with ideas. So you say, here's our data, here's a snapshot of roughly how our business works, and then data scientists who actually understand the capabilities and limitations of machine learning will write little proposals. Well, they'll say, if you had a machine learning model that did this, which I think is possible, by the way, because I build these kind of things, this is how you could use it in your business, and this is the impact it would have, and I had a quick look at your data, and it looks like there's some signals in it of these kinds. The community, again, of data scientists votes on these, and so you can then pick from the top voted proposals to say, okay, actually that one is really in line with our business.
So that would actually, we like it, and a lot of people think they could actually solve it.
Right.
Yeah.
Right. And so what normally happens from a Kaggle Prospect is you then just take that and it automatically turns into a regular Kaggle machine learning competition, because you've now got the data there and you've got the information there.
And how much does it cost you to launch a competition?
The cost of launching a competition, whether it be Kaggle Prospect or Kaggle modeling, varies a lot. For example, small startups, there's generally no fee that they pay Kaggle, because we're just trying to encourage people to use this technology to make a difference. For commercial enterprises, it depends whether they are creating what we call a public competition, which is the kind you see on our website all the time, where the data and the problem and the client name are all open,
Right.
or a private competition, which is where 15 of Kaggle's top data scientists are invited to compete against each other on your competition in secret under NDA.
Do I choose which 15, or do you work with me to identify the 15?
We actually have algorithms that can automatically identify the
Of course you do.
15. And so those 15 are picked not just on their past performance, but also on how different their solutions have been to each other. So you get a really
Nice
varied
mix.
group.
And so in that private competition, my competing companies or competing entrepreneurs don't know I'm running it.
That's right.
So that's the advantage there.
And they can't get access to your data.
Right.
The IP is handed over in secret and so forth. So generally speaking, for a moderate-sized company running a moderate-sized competition of private kind, they're looking at normally about $100,000 in prize money and about $100,000 in fees.
Which is still extraordinarily, reasonable for compared to the value you get out. Because if you're going to hire a few data scientists to work on this for a year, you'd end up spending that much money easily, if you could find them.
You would, absolutely. And at the end of it, you wouldn't know
whether you have the best solution.
And it's going to take longer. And in the end, it definitely won't be as high a quality model.
So how many total competitions has Kaggle run to date?
I don't know the exact number, but it's
Roughly.
over 100.
Over 100. And if I were going to, so give me your vision, because you are a visionary guy, of where this is going. So in 5 years' time, what is Kaggle doing? What is this whole field doing?
I really see it changing the nature of how work is done and the nature of how people are rewarded. So I see people picking what they want to do that day from thousands or tens of thousands of options. Algorithms helping them find the things that might be of most interest to them, where they might be most capable of contributing. Algorithms identifying who the best people for them to work with on that might be. These kind of short-term micro tasks. And then they're going to be rewarded for what they're doing based on their actual performance, not based on what school they went to, or not based on who their family are, or so forth. It'll be a real meritocracy. So I see Kaggle making a huge difference in two places. One is shifting the technology curve in machine learning and AI, which is this number one most leverageable area of technology. Mm-hmm. And secondly, in changing the nature of work so that humans themselves are going far beyond what they're capable of doing in the past.
I want to close with this. Kaggle probably would not have been possible 20 or 30 years ago. What are the technologies that exist today that make it possible?
So I started doing some big data analytics 20 years ago when I was at McKinsey & Company. I was in Australia at that time, and there would have only been 2 or 3 companies in Australia able to leverage these technologies. It was just damn expensive. For one thing, we had to buy custom neural network silicon hardware. There was only one vendor that had it. We had to buy these very expensive, massive databases from Teradata. And then even the number of companies that had that amount of data was tiny because things weren't being run online where everything was being captured. So 20 years ago, access to just this data platform was very, very, very rare. A couple of companies in Australia, maybe a dozen in America. It's very, very expensive. And furthermore, the algorithms in machine learning, these kind of meta algorithms for teaching computers how to learn, were pretty rough. There weren't that many things that they could do, and they required a huge amount of tuning. And a lot of the time, they just got it wrong. So today, we have open source free software, which run machine learning algorithms that are far beyond the capabilities of anything that was available 20 years ago. And of course now we have the massive connectivity of the internet, which allows people from Slovenia or Australia or the US.
How many countries do your 45,000 data scientists come from?
Well over 200.
200 countries.
Mm-hmm.
Amazing.
They all come together, they work against each other in competitions, they work with each other as collaborators.
What's the average size of a team?
Most teams would be about 2 people.
Okay.
Many people work alone. Although we find as people are with Kaggle for longer, they tend to join bigger teams, I guess, as they get to know the kind of people they're working with.
And they learn from those collaborations as well, probably.
Very much so.
Wow. And going forward, I assume that machine learning is going to increase cloud computing capacity, speeds, ability for people to interconnect. I mean, it's just going to get better and better.
Yeah, so over the next 5 years, the number of human beings connected to the internet will be like double or more.
Yeah.
There will be billions of new minds that we can access. The ability of people to work together will be greater because there will be more and more handheld devices with more and more capability. The power of machine learning algorithms will continue to improve. More and more stuff will be automated, simpler. The patterns it can recognize will be more sophisticated. I also think I hope there'll be a cultural change. I hope that companies will move away from the not invented here syndrome. They will start to be prepared to accept that there could be somebody in Bolivia who is better at analyzing their credit scoring banking data than anybody in their highly paid banking team. Now, this is a cultural thing which a lot of people are finding hard to get their head around and hard to accept. And it should be that if you use an entirely in-house team to develop a predictive model, you should have to justify that to your board. They should be saying, why are you not harnessing the greatest minds in the world, as we find them? We're finding right now it's the opposite sometimes. They're getting the question, why are you not doing this in-house? When the answer should, of course, be, why would you not use the best minds in the world, wherever they are?
We've talked about the success cases. What are the failure modes? How do people misuse a Kaggle competition?
The place that we found we tend to have to get involved and redirect people a little bit tends to be around aiming far too low. So, for example, people interested in marketing will often say, we'd like a segmentation study. We'd like to kind of understand what kinds of customers we have. And we'll say, well, why do you want to do that? Well, it'd be interesting, and we could maybe do things like target some of our marketing actions a bit better. And then I'll say, well, what if you had an algorithm that could optimize every single marketing interaction you have with every single one of your customers over their entire lifetime? Wouldn't that be better than a segmentation study? And they say, well, yes, is that possible? Well, let's find out. Probably. So we find aiming too low is a big issue, particularly people looking for descriptive things. They're just creating more data rather than optimize things, which is actually figuring out the best thing to do.
So a few more how-to questions. You put up the data set, you have the very specific question. How do you market that competition to your data scientists? If it's an open competition.
Yeah, so for a public competition, we have a regular newsletter that goes out to everybody registered on our site.
Right.
There doesn't generally require much marketing. We find that at the moment, researchers are and people interested in data are always interested in, oh wow, there's another data set I can look at, there's another problem I can play with. So we find at the moment, without us doing anything, hundreds of people come and look at every competition, and in fact, often we get many, many new sign-ups to Kaggle for every new competition.
And how long does a Kaggle competition go for? What's the typical timeline?
Generally speaking, competitions run for 3 months. Private competitions might run for only 2 months, but we have had competitions that run for as short as 24 hours. For example, we just ran one last weekend for EMI, which was looking at people's tastes in music, ran for just 24 hours. We also have a competition that's running for 2 years that has a $3 million prize and is looking at predicting people's hospitalization in order to improve healthcare.
Great, great. Well, Jeremy Howard, President and Chief Scientist at Kaggle, a real pleasure.
Thank you, Peter.
Thank you.